Hello, everyone. The title of my paper is A Robust and Cascaded Acoustic Echo Cancellation based on deep learning. My name is Chenggang Zhang, and my supervisor is Xueliang Zhang. I come from Inner Mongolia University, China. If you have any questions, please feel free to let me know. This is the outline of my paper. First, I will introduce the AEC background and the motivations of my paper. Then, I will describe the proposed algorithm. Next part is the experimental setup and the results. Finally, I will conclude the paper. Acoustic echo widely exists due to coupling of the loudspeaker and the microphone in hand-free devices, such as mobile, telephone, and teleconferencing systems. The microphone captures a signal coming from its own loudspeaker and produces uncomfortable echoes. So AC is used to cancel acoustic feedback between a loudspeaker and a microphone. The echo signal Dn, which is generated by convolving a far-end signal Xn with a room impulse response. Here, Hn denotes the echo transmission path. The microphone received signal Yn consists of near-end signal Sn and echo Dn. The goal of AEC is to obtain Sn by estimating Hn using Yn and Xn. However, two problems severely degrade the performance of AEC. One is double talk when near-end signal and far-end signal appear simultaneously. Another is nonlinear distortion caused by speaker and amplifier. The proposed AEC consists of a linear filtering model and a nonlinear filtering model to deal with these two problems. In linear filtering model, a deep LSTM is employed as double talk detector to improve the performance of adaptive filtering. In detail, it is divided into two processes, double talk detection and adaptive filtering. Firstly, for the double talk detection, the most effective way is to detect the double talk in time and frequency unit level. So when we employ deep neural network to estimate the IRM can be wielded as a probability of echo appearing at TF units. If IRM is close to 1, it means no near-end signal showing up. Otherwise, it means that double talk happens. To estimate the IRM, we use 4 LSTM layers with 300 units in each layer, as shown in this figure. The next is the adaptive filtering process. A frequency domain, RLS adaptive filter with a double talk detector is employed to remove the linear echo components in the microphone signal. First of all, the RLS cost function is a sum of squared errors can be defined as follows. Then the optimization is to find a W to minimize the cost function. It should be noted that the matrix inverse can be avoided by the recursive algorithm. Next, if the IRM of current TF units is greater than LC, we update the parameters. LC is a local criterion. Otherwise, it denotes the double talk happens. So We don't update the parameters. Finally, the estimated echo signal and the linear output signal are obtained. Okay, in nonlinear filtering model, another deep LSTM is trained to suppress the nonlinear radio echoes. Input features are the magnitude spectra of Y and G signal, and the training target is a phase-sensitive mask. So the estimated magnitude spectra of near-end signal is obtained. For the datasets of experimental, we use the timid crops for a total of 6,300 utterances that sampled at 16 kHz. We generated 5,200 pairs of signals in total. 4,000 pairs are used for training, 900 used for validation, and 300 used for testing. We generated 7 different RLRs and randomly chose 6 RIR to generate echo signals for training and use the remaining RIR for testing. For training and the validation side, we generated the microphone signal at SER level randomly chosen from -6 dB to 6 dB. For testing mixtures, we generated the microphone signal at 4 different SER levels. And we used 2 metrics to evaluate the AC performance. One is the ERLE for single talk pairs. Another is Pascal for double talk pairs. More specifically, as depicted in the figure, the 2 dashed red boxes are single talk, and the dashed green boxes is double talk. For the first experiment, we evaluated the proposed method in double talk situations. NCC-NLMS denotes the NLMS algorithm combined with the normalized cross-correlation double talk detector. And LSTM denotes an end-to-end learning method, which has 4 hidden layers with 300 units in each layer. As shown in this table, the best scores in each case are highlighted by the boldface. The second is experimental of music echo. This is evaluate the generalization performance of AEC to music signal echoes. From the table, we can see that LSTM is invalid for untreated music echoes. The third is experiment of nonlinear distortion. We simulated the series nonlinear distortion echo captured by the microphone after passing through a power amplifier, loudspeaker, and acoustic transmission in order. Equation 1 is hard clipping. Equation 2 is memorized sigmoid nonlinearity. And equation 3 represents convolving with RIR. Since the NLMS is not capable of dealing with the nonlinear distortions, second-order Waterall adaptive filter is employed to cancel the nonlinear echo in the microphone signal. Experimental results show that the proposed method outperforms the traditional method, and we also found that the proposed method has good generalization performance. Okay, thank you for your listening.